Hey guys, so today we're going to be doing the quiz review for factoring. So you're going to be taking that tomorrow. So I just wanted to go through all different types of examples with you, show you how to do them, remind you of some little things that might pop up. But always feel free to email me if you have questions in the meantime. Some of these are directly from the packet, so I kind of took ones that I thought people would have questions on. So if they look semi-familiar, that might be why. But I wanted to show you these. So this is the review. I will post this on Google Classroom as well. And I will leave a copy somewhere in my room for you if you can grab it. So let's go through and do it. So no matter the problem, your first step is to always look for a GCF. That's always your first step. So it kind of just randomly pops up. It's not going to happen all the time, but if it does happen, you want to see it. So please just do a quick scan when you're doing a problem and see, is there a GCF? Some other things, how to organize your information. Always make sure your terms are in standard form. So from highest exponent to lowest. So you might have to do a little bit of rearranging, and always make sure your first term is positive. If it's not positive, you would just take out a -1 like a GCF to make it positive. So that's something you want to do. So if you have a trinomial, so you're just starting your life, these are probably the ones that you saw the most last year. So hopefully you are familiar with them. You basically just make sure it's in standard form. Number one doesn't have a GCF, other than obviously everything's divisible by 1. So we're good. We can kind of get started. To factor it, I'm dividing it into 2 binomials. I'm just going to find my factors. So 12 x squared, I can either have 12x times x. What else can I do? 6x times 2x or 4x times 3x. And for 63, I can have 1 and 63, 3 and 21, or 9 and 7. So just remember a few little tips. I always kind of write things out in order and then work backwards. So you always want to work with the factors that are closest together first. It usually just saves you a little bit of time. So I'm going to start with 4x and 3x. And then I'm going to put in 9 and 7. So just as another reminder of little things that we've talked about, you can never put common factors together. So I cannot put a 9 right here because those would have a common factor. So I'm going to try the 9 here, the 7 here. And then I'm checking, is there a way that I can distribute and make this middle term? So that gives me what? 28x. That gives me 27x. I'm feeling good about life because with opposite sides, if I have positive 28, negative 27, that gives me 1. So I fill in my signs and I'm done so. All right, so not too terrible. It's really just about that guessing and checking step and making sure you have all your factors. So as I'm looking at number 2, I'm like, hey, wait a second. This is not in standard form. So that's what I need to do first. Put it in standard form. I have 18x squared minus 16x plus 24. And then I also notice, quick scan, there is a GCF of 2. I would be left with 9x squared minus 8x plus 12. And then I start to go in and kind of just see what can I do from here. 9 is either 9x times 1x or 3 times 3. 12 is either 1 and 12, 2 and 6, or 3 and 4. And as I start to kind of think about plugging in, I can't even use this 3x and 3x because there's going to be a common factor there, a common factor there, a common factor there. So that's out. So we have 9x and 1x. I don't know if this is going to work, guys. Let's just checkaroo. If I try 9x and 1x, I can't put the 3 here. So let's try the 4 here, 3 here. I should have done this in pencil. Oh, sorry, you couldn't see half that. That gives me 27 and 4. That's not going to give me 8. That's out. If I try 9x and 1x with a 2 and 6. Oh, hold on.
Good morning, Bridgewater Raintown. Please rise for the pledge of allegiance.
Second. Oh no, can I pause this?
I pledge allegiance to the flag of the United States of America.
I'm sorry, because you're just going to have to listen to this, which is torturous. I'm going to just do my work as you're listening.
Indivisible, with liberty and justice.
I'm on the right page, sorry.
Please
So
remain
give me a
standing for a moment of
second. Let's try 2 and 6. I can't put 6 here, so let's try 2, 6.
Please
That's not
be
going to
seated.
work.
One announcement today that I can see is that tomorrow is Pajama Day for Spirit Week. And
PJ
next
Day.
week, on Thursday,
That's not gonna
Pick
work.
Your
Okay,
Decade Day.
so nothing's
And
gonna
on
work.
Friday,
So
it's Hawaiian
GCF is just
/
gonna be
Beach
my
Day.
answer.
Keep it real, everybody.
All right, sorry about that announcement there. I was trying to get going early here. So I tried all the options. Nothing's gonna work. So if nothing works, GCF is factoring. The GCF is just your final. So then you're done with that one. Okay. So you might have to do a little bit of extra workout, but I suggest a pencil as I'm doing this in pen, but you get the idea. So then we come down here. Oh, x to the fourth, that's just x squared times x squared. 25 is either 1 and 25 or 5 and 5. I can kind of see that it's going to be 1 and 25 because I get 26. So I'm going to throw that in because it would be -1 minus 25. Okay, because that would give me -26. Now, it's something you always want to look for, and we talked about this in class. As you factor, see, is there anything I have to keep doing, or is anything still factorable? Because what happens is this is actually a difference of two squares, and that's actually a difference of two squares. So we can keep factoring both of those. So you do need to factor completely. That would factor to x plus 1, x minus 1, and that would factor to x plus 5, x minus 5. And that would be your final answer. So please just make sure you're factoring completely. Always check once you've done the step, is there anything else I can do? And then we get to number 4. There is a GCF here. Sorry, I keep like having weird things. I'm trying to zoom in. There is a GCF. These are all divisible by 3. And what I also notice is, and this is something I mentioned before, you always want to make sure your first term is positive and this first term is negative. So as I take the 3 out, I'm also going to make that a -3. And they also have an x in common. What that's going to do is take care of that sign for me as well. I'll be left with 12x squared minus 95x minus 8. I'm going to be honest, I'm going to be a little lazy right now, and I'm just going to tell you the answer. You can do all the factors out of 12. 12 times 1, 6 times 2, 3 times 4. 8 is 1 times 8 or 2 times 4. And it should factor to 12x and 1x, and then 1 and 8. Plus minus, you're good, because that would give you 96, and that would give you 1, and -96 plus 1 is 95. I just got a little lazy there and didn't feel like writing the factors out, but hopefully by then you kind of get the idea, and that's a good review of stuff you guys did last year. So then I try to set it up by like setups of different problems. So that was trinomials. This one we have all binomials. So if you have binomials, you have a few options. It can be a difference of two square problems. It can be a difference of two cubes, or it could be a sum of two cubes. So now, where in the past maybe you just knew difference of two squares, you have a few more options. So you have to just look at what do I have and what makes sense for that problem. It doesn't make sense that we would have cubes here because that's to the 4th power. So this is going to be a difference of two squares. We're going to use square roots to help us out. So that would factor to 4x squared plus 25, 4x squared minus 25. Always check your answer because this is a difference of two squares. This is not. That's a sum of two squares, which we can't factor. So that stays as 4x squared plus 25. But this can factor to 2x plus 5, 2x minus 5. And that, my friends, would be your final answer for that one. So just some other things as I'm doing this one, I always check for a GCF as my first step. These are divisible by 2c. So that would give me, I'm just making sure I'm right. 16x to the 4th minus what's 162 divided by 2. 81, no, y to the 4th. All right, so let's factor 2c. If I'm just using square roots, that would be 4x squared minus 9, or I'm going to say plus 9y squared, and then 4x squared minus 9y squared. And just like with the other ones, check. There is a difference of two squares there. So your final answer is 2c, 4x squared plus 9y squared, and then 2x plus 3y, 2x minus 3y. And that is your final answer. So you see it pops up a lot. Be on the lookout for that. All right. Okay, so then we go to the next one. We say, wait a second, that's not a difference of two squares because I can't take the square root of that or that. So that's your kind of hint. Always look for that cubed, that this is a difference of two cubes. So we're going to use cube roots to help us. So basically, I'm going to take the cube root of the first term, which is x. I'm going to take the cube root of the second term, which is 5. And I keep the same sign. So for my first binomial, so your cube roots keep the same sign. Then for your trinomial that you need, you're going to square the first term, opposite sign. You're going to multiply those things together. Oops, opposite sign would totally be a plus. Mrs. Sherman, you know. And then always positive, you square the last term. And that would be your factor form. So that's just kind of knowing that process, that little formula that you're plugging into, and how to get it. So this one, same idea. This is a sum of two cubes. So I'm going to take the cube root of the first term, that comes out to 5x. I keep the same sign. I'm going to do the cube root of the second term, which would be 7y squared. So everything, the rest of it's kind of based off that. So it's important that you got that binomial. So then from here, I square the first term. That would give me 25x squared. Opposite sign. I multiply these together. So that would give me 35xy squared. Always positive. I square the second, or the last term, whatever you want to call it, 49y to the fourth. And that would be my final answer for that one. So once again, knowing that process is going to be important for doing sum or difference of two cubes. Okay, so that's what happens when you see a binomial. Sum or difference, oh my God, I can't talk. Difference of two squares or sum or difference of two cubes. Okay, so what happens if we have a polynomial with 4 terms? That's when we're going to use grouping. So grouping, you kind of look and see, all right, I look here, I'm going to make 2 groups. From each group, I'm going to take out my GCF. In my first group, my GCF is just C. And I'd be left with 9x minus 5y. In my second group, my GCF is 2D. And when I divide that out, I will be left with 9x minus 5y. Remember, for grouping, these binomials do have to match exactly. So signs the same, terms the same. And then to write my final answer, I take these two outside terms, put them together, and then that repeating binomial is second. Or it doesn't really matter the order, but as long as you have those two things. So what's going to happen is you're like, okay, I know how to group, and you're going to go to number 10. And if you try to group number 10 the same way, it's not going to work. So if I try to group it with just like 2 and 2, I would have a GCF of x in the first, and I'd be left with x plus 6y. But over here, there's no GCF, but it's a difference of 2 squares, and it's all sorts of confusing. So if you try to do a problem and it doesn't work, try to group it a different way. So see how this is an x squared, but then the middle has xy. It kind of should make sense that we could group it with the y squared because that middle term has both of them in common. So this one we do group a little bit differently. So just as a heads up there. I'm going to factor this. This would be x plus 3y, but then it would be x plus 3y. So I'm going to write it as x plus 3y squared minus 25. This is a difference of 2 squares. If we're going to talk about substitution in a second, but if you want to just say like this is a squared minus 25, that would be a plus 5, a minus 5. And then just go back in and plug in what a is. That's x plus 3y plus 5, x plus 3y minus 5. And that would be your factor form. So that one's grouping, but it's a little bit different. If you try to group with your normal like 2 groups of 2, it wouldn't work. So if something doesn't work, just try to group it a different way. So in that case, since I saw that xy, it kind of made sense that I included the x squared and the y squared in my group. This one, I'm just going to try my normal grouping. If that doesn't work, we will figure something out. So this has x squared in common, and I'd be left with x minus 2y. This has 25 in common, but what I notice is, remember, I need my signs to be the same. So since this is positive, negative, I need to switch the signs of those. So I'm going to make that a negative 25, and I'll be left with x minus 2y. When I put it in factor form, that would be x squared minus 25, x minus 2y. Hey, difference of two squares. It pops up all the time. Be on the lookout for it. So that would be x plus 5, x minus 5, x minus 2y. There you go. So grouping, you have 4 terms. You're just doing your best to group it so it makes sense. So it's something that you can factor. So then on the back, because I'm trying to kind of show you all different types of things. Ooh, what if we have a polynomial with 6 terms? That sounds kind of fancy. So what I would say is, hey, that's a lot of stuff. So I want to do some more grouping. So once again, since you have x squared and then you have xy, hopefully it makes sense that you include that y squared as well. Those all kind of go together. Here you have 4x and 4y. So those have a 4 in common. So let's group those and then we'll just see what we do with that 45 in a minute. So let's factor this. This would factor to just x plus y. So I'm going to write it as x plus y squared. This, I would take out a GCF of 4, and I'd be left with x plus y. And then we have minus 45. Hey, wait a second. This looks like a factoring by substitution, which we're going to do right here in a second. Problem. That's exciting. Let's say instead of x plus y, I'm going to replace it with a. So a squared plus 4a minus 45. We use substitution because it makes problems easier, right? Because this is a lot easier to visualize what should happen with the factoring. That would factor to a plus 9, a minus 5. And then I can just replace my a with x plus y. So that would be x plus y plus 9, x plus y minus 5. All right, so fancy schmancy there, 6 terms. You're just making a few different groups. Same thing goes here. Oh, okay, a squared, but ab. So hopefully that makes sense that the b squared we can factor together. And you have minus c squared, cd. Ooh, so I'm going to try that as my 2 groups and kind of see what happens. So factor this. That gives you a minus b squared. Okay, that wasn't that bad because it would be a minus b, a minus b. Here, though, I don't want to factor this yet because that first term is negative. So take the negative out. You'll be left with c squared plus 2cd plus d squared. So that would be minus, and that would factor to c plus d squared. So once again, if you want to use that substitution, you can say a is a minus b, and b, I'm sorry, because there's all sorts of weird letters here, is c plus d. A squared minus b squared would just be a plus b, a minus b. So then fill back in. So that would be a minus b plus c plus d. And then just be careful on this one. It's a minus b. You're subtracting the binomial that's b is representing. So when I say minus, I'm subtracting both of those. So it would be minus c minus d. And that would be your final answer for that one. All right, so some funky stuff is happening, but hopefully we're organizing it in a way that we can kind of relate it to factoring that we already know. So we had just kind of seen substitution up here. So let me do these problems, and then I'm going to leave the mixed review for you guys to do, and I will post my answers on Google Classroom just so you can practice and see, is there a problem that I can kind of refer back to? Is there anything that I cannot do? Because those are the questions that I need before you take your quiz. So substitution, I always just use a because why not? You can use any variable or any placeholder that you like. So I'm going to say in this one, a is going to equal x plus y. Anytime I see a binomial, I usually do it. I just think it makes it way easier. So I'm going to say that's a squared plus 14a plus 48. So that doesn't look too terrible to factor. That's going to factor to a plus 8, a plus 6. And now that I have that, I'm just going to go back and replace the a with x plus y. So x plus y plus 8, x plus y plus 6, and that would be your factor form. Okay, so nothing too terrible. Once again, don't overthink it. They look confusing. See if you can rewrite it in a way that makes it less confusing. So same thing here. I'm going to say a is, in this case, my binomial is c plus 2d. So I'm going to write it as 5a squared minus 13a minus 6. Excuse me. So let's factor that bad boy. That would factor to what? 5a, and that would just be a. So 5a minus 2, 5a plus 3, because that would give me Wait, I did my signs wrong. Right? Because oh, no, that's a plus. All right, I knew I did something wrong. Okay, that makes sense. 15 minus 2 gives me 13, BUDS, and then just go replace your A with your C plus 2D. So just be careful. So it's 5, and then C plus 2D minus 2, and then C plus 2D plus 3. I am just going to do a little simplifying here, like I'm going to distribute into that. So my final answer would be 5C plus 10D minus 2, and I'm going to have to write my other one down there because I ran out of room. Oops, sorry. And that would be my factor 4, my two binomials. Sorry, I didn't write them next to each other. But you do want to like simplify as much as you can. If you see that you can distribute something, please do so. All right, last two. Let's do a little substitution. I'm going to say A is m minus n. I'm going to say B is x plus 2y. And really all I'm doing is a squared minus b squared. Nice little difference of two squares there. So that factors to a plus b, a minus b. And then we can throw back in our binomials. So that would be m minus n plus x plus 2y. M minus n, make sure you're subtracting b, which is a binomial. So both of those need to be subtracted. So that would be minus x minus 2y. So just as a reminder there, just little things. We want to be on the lookout. Those are the little mistakes people make. And last but not least, let's throw it in. A is c plus d. So we have 3a squared minus 7a minus 20. We're going to factor that. So what's that? 3a, I think that's 5 and 4, because that would give me 12 and 5, and if I had negative 12 plus 5. Perfect. And then once it's factored, you just throw your binomial back in. So it would be 3 times c plus d plus 5, and then c plus d minus 4. So my final answer would be 3c plus 3d plus 5, c plus d, I'm trying to stick it in, minus 4. I'm trying to snug it in there at the end. All right, so beautiful. So we have a lot of different cases, some of them new, some of them you already knew how to do, some of them kind of just built on what you knew how to do. If I could talk, that would be delightful. So at the bottom, you have a mixed review. So basically just a bunch of problems you're trying, things like writing in standard form, making sure your coefficient is not negative, or your leading coefficient is not negative, doing things like looking for GCFs as you're doing problems, because you are always doing that. Recognizing, hey, there's 4 terms, I should group. Hey, there's 2 terms, what special case is that? Hey, I see binomials, maybe I should use substitution. So little things as you're going along. So hopefully you're starting to recognize those things. I did want to just point out 23, just the way it's written. I have 5x, and then I have 3 minus y, and then I have y minus 3. So this is actually already kind of like grouped for us, right? But we know that if we're grouping, that these binomials have to match exactly. So just think about it. If this is y, it doesn't matter which one you pick. If this is y minus 3 and this is 3 minus y, just flip the order. That's really negative y plus 3, right? That does not match. The nice thing is the terms match, it's just the signs. Excuse me. So you can take a negative 1 out. So you can rewrite that. Oh, I should have done it to the other one. I'm just going to pretend I didn't do that. You guys good with that? Perfect. Okay. Yeah, not Mrs. Sherman. Okay, I'm going to do it to this one. So if this is 3 minus y, I'm going to flip the order of these. It's negative 3 plus y. And I'm going to take a negative out. Sorry, I just don't want my leading coefficient to be negative. That would have been yucky. I'm going to take my negative 1 out, and that's going to become 3 minus y. And now they match exactly. So I can rewrite this as 5x, 3 minus y. If I take that negative out, and there's already a negative there, that would become plus 4, 3 minus y. And then when you factor, it would just be 5x plus 4, 3 minus y. All right, that was way harder than it had to be. Sorry about that one. Okay, so hopefully you have a general idea. I will be posting this. I'm going to give you a better view here. I will be posting this on Google Classroom with the mixed review filled in. So please feel free to go and check, kind of check yourself. Are you okay with different setups and what to do. Feel free to email me if you have any questions. You do need to know how to do sum or difference of two cubes. So that's something you may want to study tonight and get used to. But in the meantime, just let me know if you have questions and we'll go from there. Have a great day. Thank you for watching.